So, first up, your summons. Review. I told you only half jokingly, you don't get a choice.
There you go.
Yeah. Okay, everyone got one? So, the math competition is coming up, and every one of you, I would feel confident in any one of you going to that. It's just there are some who are consistently known to teachers, like usually this level of detail, so we say like, hey, you should do this. That level of detail usually involves a lot of questions. And call it what it is, yesterday was train wreck, right? So, third hour, if you want to go watch that video, we finished everything with 28 minutes to spare. So I also went through the end of the year, like schedule, where the assignments and everything are going to line up. Seniors, we had 2 in here, right? 3. Really?
4 actually.
Huh.
What? Quattro.
I could have swore you were okay. I don't know what I'm going to do with you, because seniors in PreCalc is weird. Second semester. First semester, yes. Second semester is usually only got like 1 or 2. This semester I've got like 8. Normally what would happen is I would give you the chapter 10 or unit 10 stuff on sequences and series. You do that on your own, on the side. It's the easiest of the entire course. It's literally formula plug and chug. I think you've done that in the new Algebra 2 curriculum, depending on when you took Algebra 2, right? So normally I would be content to just hand you that on the side. You would do your final, usually when we're starting chapter 10, the last few days of the school year, and it's easy peasy. Them deciding not to extend our school year means we just lost 3 days. That means I thought we were on track, now we're hurting. Where I'm going to have to triage through chapter 10 anyway. And that's assuming that we don't have any snow days or anything like that. So that puts your potential final right in the middle of when we're doing chapter 6 stuff, which is like partial fraction decomposition, matrix operations, solving by matrices, and that's a whole different animal. Because I don't know that I want to hand that to you and say do that on the side on your own. Depends how comfortable you are with finely detailed, there might be 45 individual arithmetic calculations in one problem. I might also just say, the hell with it, don't do your final. I don't know. I got to see how the next few weeks shake out, okay? So I'm sorry I don't have a better idea for you, but not getting those extra couple of days just kicked my plans right in the nethers. I don't know what to do with it, okay? I'll figure it out in the next few weeks. But yesterday, with third hour, I did go through all of that stuff. Today's quiz is not on your midterm. I said your midterm will include the last 2 quizzes, 7 and 8. I will get packets in, but they won't be in until tomorrow after the midterm is already posted. If it affects your eligibility, which I don't think it will for anyone because everyone's passing, doing fine. If it affects in or out of Spartan time, I'll just contact your Spartan time teacher. I think across both classes, I've only got like 1 or 2 kids who are near D range. So I don't think it's going to be an issue, but I will update it with those teachers if it's an issue. Okay? It's just, I'm not going to get the packets done before I have to put in the grades. Case in point, I was up at 11:30 last night with one screaming child. I've been up since 4 with the other one. They're both sick now. So I just ain't getting crap done at home. Everyone's got the review. What? What? Oh, probably just saw a piece of paper in front of you and went for it. So, here we go. We've done 4-1, 4-1, 4-2, 4-2, a little bit of 4-3. And it's all about trig stuff. So if you were a little bit behind on the other stuff, so long as you kept up in the last 5 days, you should be good to go. Starting with review of right triangle trig. SOHCAHTOA Pythagorean theorem. I find angles with arc functions. All boils down to this. Every bit of this is review of geometry. If I'm looking for a side, do not find the angle and then use the angle to find the side, because I can do Pythagorean. Now, I'm not saying your test is going to look like that. Your test might have, I don't know, might have 2 of the sides, 1 of the angles. In which case you'd subtract from 90 to find the other angle. You'd use the angle and the ratios to find the other stuff, okay? I don't know, it's a grab bag. That's how solve right triangle works, is I give you 3 pieces of information, you find the other 3, okay? So starting with this, what do you want to do? Angle, side? Okay, so we'll start with the side. Remember that when you do Pythagorean, you can either old school a squared plus b squared is c squared, or you could shortcut it that the hypotenuse is square root of leg squared plus leg squared, or the leg is the square root of hypotenuse squared minus leg squared. And tell you what, a pre-calc student feels pretty silly if they screw up Pythagorean theorem, because in this case they added together 20 squared and 35 squared. Okay, watch your signs, watch which one's going where. For my key, the way that I usually do it is just write this part out. And I'll say length CB, or little a, is, that's why I usually don't have people over there, because they're just staring at my back the whole time, square root of 35 squared minus 20 squared. Which is 35, 900, 150, 300, 1200, 1225 minus 400, square root of 825, which is 5 root of 33. Okay, always simplify too. Man, that sucks to remember to do the Pythagorean and do it correctly and get the radical, and then you don't simplify it. After that, find angle A or B. You have a choice, and it doesn't matter which one. What matters is that I can't just say sine, cosine, or tangent, because now I'm finding the angles. Remember, normally, regular ratios, I put in angle, I get out ratio. I don't have an angle to put in. I will put in ratio, and I will get out an angle. So I need to make sure to do arc functions. Arc functions are sine to the negative first, or arc sine, or cosine, or whatever you choose. If I'm going from angle B, I'd say measure of angle B is arc sine, because I have opposite and hypotenuse from this angle of 20 over 35. You can reduce it down to 4/7 if you want. Or I could have done, I do that a lot. Arc cosine. Arc cosine, because now from this angle, my opposite and adjacent will swap. Now, I don't recommend using this just because if I goofed, I get a domino effect error. But if you trust yourself that you did it correctly, go ahead and use it. Okay? It's now available information. But I'm going to stick to what I have already presented in the problem, just in case, because I don't want to domino effect my way through the answer. You don't have to do arc function for both of them. Find one, subtract from 90 for the other. If you're going to subtract from 90, please show it. So like maybe I did arc cosine for this guy, getting about how much? Is it actually cut off there?
No, it's 0.095.
Okay. So when I go to show the other angle, just because you want to show a little bit of work, so if you goof, I can still give you that partial credit. I would say the measure of angle B is 90 minus measure angle A, and then say that is about, what, 3485? Okay, so show me what you did to get it. Even if it was just mental math, even if it was just 90 minus answer, show me what you did, because I always want to give you credit. What happens if you went and found the measure of angle A and forgot to get back into degree mode? Who's looking at the top of their calculator and checking their mode? When was the last time you reset it? What if you reset it right before we start every quiz? Okay? I don't want you to get got. And if you write those out, I can still give you credit for that, even if you do. All right. You had to know it was coming. We spent enough time on it. Oh, yeah. Oh, hey, I'm even wearing a red shirt. Yeah. Kool-Aid Man. Sarah stands on the ground and, well, it's got to be Sarah because then it's stick figure Sarah. Sights atop of a steep cliff at a 61-degree angle of elevation, steps back 50 meters, and now it's at a 32-degree angle. If she's 1.8 meters tall, how tall is the cliff? A note to add to this, remember, if they tell you the height of the object or the person or whatever it is, you have to include it in your calculations. If they don't tell you, don't worry about it. Okay? So I start with my stick figure drawing. I'll keep it simple this time with just triangles. So we've got a angle of elevation of 61 and 32. Which one's where? How do I know? Okay, the one closest to the object will always be the bigger one because you have to look further up when you're closer to it. Okay, so here's 61 degrees, here's 32 degrees. And it says stick figure Sarah is going to back up 50 meters. So I know from here to here is 50. And we want to know how tall the cliff is. So that's going to be x at the end of it. And, okay, glad you're saying it now, otherwise we would have had to add it in at the end. Remember, I'm going to find x with this triangle. I am still going to find x, but I have to remember that if stick figure Sarah is 1.8, then whatever I get for x, I need to add 1.8 onto it, because it's from her eyesight. Okay, if stick figure Sarah is 1.8 meters, this triangle is from a 1.8 meter elevation above the ground. because her line of eyesight is parallel to the ground. So I'm going to go find x, the same that we did. It's just at the end of the problem, I have to remember to also add in 1.8. Most common mistake on these. Kids run all the way through the problem perfectly. They forget to tack that on. Okay? Then I'm also going to need something to denote that space. So we've got the little triangle, which is 61, x and y. And then we've got the big triangle, pink, which is 32, x, and what's the base now? For the whole triangle, the big triangle. Now I have to tack on the 50, right? The whole base is y plus 50. So if I write out those two tangents, because it is opposite and adjacent, we've got tangent of 32 is x over y plus 50. We've got tangent of 61 is x over y. I'm going to do this so I can get a little more writing space here. Imagine when I used to cram all 6 of these onto one page. A little too much. A little too much. That's all the setup. Most of us are fine with the setup. Where do I go from there? You got too many variables, so you're going to have to isolate one of them and substitute. Okay. The easiest that I recommend, swap your extremes. Remember, that's the same as cross multiply solve. Over here, I would get y plus 50 is x over tangent of 32. This one multiplies, cross multiply, or swap extremes. I'm going to say y is x over tangent of 61. So if y is stuff, I can replace y with stuff. And get x over tangent of 61 plus 50 is x over tangent of 32. This is a but uglier version of just saying 7x plus 50 is 13x. It's just a nastier version of that. X stuff to one side, whether you want to factor out x or say I've got this much x, divide. Okay? It's just a nastier, ugly version of that. I want all my x stuff to one side. Getting 50 is x over tangent of 32 minus x over tangent of 61. I can factor x out. Okay? It's going to be nasty. Colors. Running out of colors. We'll go back to white. I got 50 is, if I factor an x out, there's a little invisible 1 right here and here. This is 1 over tangent of 32 minus 1 over tangent of 61. Now I think where I made some of you cross-eyed and, well, honestly just mad before, is I simplified this expression. You need common denominators because those are fractions. And then when you divide by a fraction, you multiply by a reciprocal. and you ended up with a really nasty looking result. Your nasty result would be, what's that? So 5, tangent of 61 minus tangent of 32, 50, tangent of 32 times tangent of 61. Okay. Could I just jam that in my calculator and say 50 divided by answer? Go for it. Okay? Just remember that whatever you find here, whether you're going to just jam calculator, divide, or you're going to simplify the expression, please remember stick figure Sarah. You're going to find x is the height of that triangle. You need to tack another 1.8 meters on it. And again, double check that you are in degrees because my angles of elevation were also in degrees. Let's see if we can all get into the same ballpark. Plug it back into those two little triangles and make sure that they both satisfy your tangent ratios. Also, if we're finding x and y, you should be able to do Pythagorean and get a hypotenuse with it. You should be able to use y, 50, and x and do Pythagorean. And then those three sides for big and small triangles would satisfy all of the trig ratios. I would do like arc tangent of x over y, and I better get 61. Okay. Anyone feel brave? What kind of numbers we got? Ooh, the village does not concur. $49.6. Uh-oh. All right. Grab the calculator. I am in radians. I need to change mine. Womp, womp, womp. I think this is probably the most time-consuming one on the whole test, too. So quit. So, I have fraction. I say 1 over tangent of 32 minus 1 over tangent of 61. Close it and say, I have this much x. I'll take 50 divided by that. I get 47 and change. And then, remember that's x, plus 1.8 for stick figure Sarah. Yeah?
I did it using x plus.
But if you do x plus 1.8 here, A, you're going to have to distribute. B, the angles of elevation would no longer be these because it would shift down. Meaning she'd have to look up a little bit. Yep, you have to add it at the end. Your angles of elevation or depression would change if you threw her height on there to begin with. And just to make sure I'm not crazy, I'm going to do that one. 50, tangent 32, close, tangent 61, close, over, tangent 61, close, minus tangent 32, close. Four hours of sleep, let's go! Caffeine!
Okay, so when I did it,
Okay.
that second one, I got my weird 66 number.
When I go back here and put it in the number solve, I get the 47 number.
Let's look through the history. Okay. 37 is not 32.
Let's see that.
But that's why I want you to write it out, though. You have it written on your paper as a 32. If I see your answer and I see your paper and your paper does not match your answer, I'm like, huh? And then I start trying stuff on my calculator. I start messing with stuff because I see that you're close. And especially if I can recreate the error, oh yeah, I'm giving you that one off domino. Okay? I want to give you that partial credit because you're still showing me all the other skills. All right. Then we started talking about radians and what angles look like on a circle and all that kind of business. So, starting with, if I was to draw a thing, where is a negative 225 and what does that negative even mean? I heard two whispered answers. Okay. The negative means I'm going to rotate downward from the positive x-axis, going in clockwise fashion. And on a normal 0 to 180, if I'm going to go 225 degrees, then that means my original goes this way, 225, right here. Now, unfortunately, it doesn't say draw and label it in degrees. It says draw and label it in radians. So I can choose to go negative 225 times pi over 180. That's my conversion factor. Or you remember breaking up your circles, breaking up the calzones. Okay? It's 1 whole pi, and then 1, 2, 3, 4. Looks like 1 out of 4 sections over to the other pi. So I could call it a negative 5 pi over 4. Either you do it with fractions or you do it with the raw conversion. All angles coterminal with it. Remember, that was just, it's always going to be the same. You start with alpha, whatever angle you're talking about. And then what? 360n. Where I have to be careful. I can't add part of a 360 because that doesn't get me all the way there. I have to say n is an integer. What if it was given to you in radians? Then I would add 2 pi n instead. Okay, now let's get some positive and negative angles in there. If that's the negative angle, because it goes clockwise, the positive angle is this way. And I can literally just write those off to the side. I can say negative 5 pi over 4 plus 2 pi. Call that 8 pi over 4, getting 3 pi over 4. I could break up my revolution here, my rotation, into sections of quarters. I got a bunch of ways where you can look at either the fraction or the raw math behind it. Either way, this is 3 pi over 4. And the negative angle. If I try to do a negative angle, well, I already have a negative 5 pi over 4, so I need to go all the way around the block and try it again. A negative 5 pi over 4 minus 2 pi, or 8 pi over 4, is a negative 13 pi over 4. And by all means, if you want to go more than the next integer coterminal, if you want to be that kid and go around 38 times, go for it. I'm counting rings. Go for it. Get creative. Have fun. I'll count rings. Okay. How do we feel about this? Because I think we're like right in the middle of this section. Wasn't that like last week when we had that snow day, or was that 2 weeks ago? Oh. I remember there was a schedule kerfuffle right around when we were doing this. Are we okay with this stuff? Add or subtract 360 or 2 pi? We okay with our radians? Are we okay with where all of them are? Where are the different angle measurements? If I asked you right now, off the top of your head, where is a negative 11 pi over 6? Which quadrant are we in? I'm hearing like 3 people whispering it. It's in the first quadrant, yes. Okay, how about this? The first slide of section 4.2, when we had the circle in degrees, remember we also wrote radians next to it. Using your notes is good. Okay, open notes for a reason. I don't want you to memorize things 98% of the time. Next week I'm going to make you memorize things, sorry. Not sorry. Okay. It's the only time, literally, in every one of my classes, from pre-algebra through pre-calculus, the only time I make people memorize stuff is literally that. And it's just because it's that integral to moving on to trig, and I know most of you are. Okay? Womp, womp. The conversions, all the way back to physical science. A clock is divided into 12 sectors, each with an angle of pi over 6 radians. Should make sense. 2 pi divided by 12. What is the angular velocity of the minute hand in radians per minute? Like, huh? You got to use a little bit of prior knowledge. The minute hand. How long does it take to go round? How long does a minute hand take to make a revolution? An hour or 60 minutes. You can choose both. Looking at what I have, what I want it in at the end, which would be a better one to start with? Okay. So I start with what I know, that it makes one revolution in 60 minutes. I want to turn that into radians in a minute. Do I have a conversion to go from revolutions to radians? How many radians to one revolution? 2 pi. And who goes where? Numerator, denominator. Okay, revolution go downstairs so that we can cross cancel. One revolution is 2 pi radians. And revolution with revolution, I am now radians per minute. 2 over 60 reduces to 1 over 30. This is pi over 30 radian per minute. Now, I don't believe you should have to memorize things, but there is some common knowledge that maybe we should just go over real quick before we move any further. We know that 1 revolution is 2 pi radians is 360 degrees. This was talking about minutes. You should know that there are 60 seconds to 1 minute. You should know there's 60 minutes to 1 hour. You should know there's 24 hours to 1 day. You should know there's 7 days to a week, that there's 52 weeks to a year, that there's 12 months to a year, 365, if you choose to say 0.25 days per year. Okay, we know all that stuff. Do we know how many inches in a foot? 12 inches to a foot. Do you know how many feet in a yard? Do you know how many feet in a mile? 5280. 5,280 feet to a mile. Do you remember how to go back and forth in your metric system? How many millimeters in a kilometer? 1,000 times 1,000.
Look at me, I'm on a roll today.
Okay, so if there's a conversion factor that you don't know while you're doing your test, go ahead and ask, okay? I will give you the conversion factor, or if you just want to check that you have it right, I will tell you that. But I'll say I'm not going to use anything weird. It's not going to be like how many rods to the hog's head, okay? Dude.
Can that please be the last point?
Oh, okay. So horse. Oh, okay.
Hold on, that's going in the cookbook.
I heard hands to the hose and I was worried. So, what is the linear velocity of the second hand of course on test day? What is the linear velocity of the second hand in feet per hour if the second hand is 10 inches long? Start with, what do you know about second hands and their angular velocity? 1 revolution in how long? Okay. Now you can say 60 seconds, you can say 1 minute. Look at where I want at the end. I want to go to hours, so the bigger I can make my units at the beginning, the better. So I will say 1 minute. If you start at 60 seconds, that's fine. You'll just convert seconds to minutes, minutes to hours. Okay. I have 1 revolution per minute, and I want to go all the way to feet per hour. Do you want to take care of the linear portion of that or the time portion first? Time portion is only a single conversion, so let's get it out of the way. There's 60 minutes to 1 hour. And minutes with minutes. Okay, I'm now in revolutions per hour. What was the gateway? How do I go from angular over to linear? Remember that 1 radian is 1 radius. This is length. This is rotation. So I need to get revolutions over to radians to start with. We already said 1 revolution is 2 pi radians. Cool, I'm at the portal. I am at the gateway. I am in radians. And since a radian is a radius, I know that the radian can cancel with what? If you need this, you don't have to put this part in here. If you need 1 radian is 1 radius, and then tell me that 1 radius is 10 inches. You can. Because it told me the second hand was 10 inches long. Second hand. Find the velocity of the second hand. The second hand is what's spinning, not the entire clock. On clock, I'm finding this. The second hand. Find the speed of the second hand itself. So the second hand being 10 inches long means its radius is 10 inches because it sticks out from the center of the circle or the clock that far. You don't need the yellow part if you don't want. Okay? I'm putting the yellow part for those of you that need it. If you can go directly from radians with radius is 10 inches, cool. All right, let's get some cancellation here and see where we're at. Revolutions goes with revolutions. Radian goes with radian. Radius goes with radius. I am now in inches per hour. Getting closer. Now we need to say that there's 12 inches in a foot. And then finally, there is 5,000 to, oh wait, it's just feet. Don't have to go to miles. Feet per hour, not miles per hour. Okay, so inches with inches. Now remember, when you write all this out, don't put the pi in your calculator, okay? Because I can then get a simplified fraction, pi. It'll be in terms of pi, it will be the most accurate possible. So across the top we have 60 by 2 by 10. On the bottom, just 12. Oh, that's nice. Pi. So, call that divide by 6, divide by 2 is divide by 12, 100 pi. Or approximately 314, there we go. 3141592, yeah. Get Jared back in here. Feet per hour. I finally got the story out of him too. He memorized pi just by being bored in Mrs. Work's class and staring at the strip around the room.
I used to know a kid that used 72 digits.
He has the 100. Just like, okay. Then formulas. Remember, it depends on which method you want to go. You want to go angles in degrees or angles in radians. If I'm in degrees, arc length is 2 pi r times x out of 360. If I'm in radians, though, arc length is just nicely radians times radius. area of a sector was pi r squared times how much of the circle do we got? Or area of the sector was 1/2 radians times radius squared. You get your choice. What I want you to be careful about is the wording in the problem, whether we're talking about shaded or unshaded, and which arc length we're talking about. If you don't remember how arc length works from circles and geometry, when I say arc length AB, that's the shortest distance from A to B. Now, say for example, I put D back here. To make sure you went this way, I would say it's arc ADB. Okay? But if I just say AB, it's the shorter distance between them. So, find the length of arc AB. I can either say 2 pi r by 110 out of 360, or 110 degrees times pi over 180 is 11 pi over 18 by 12.8. Remember that you can turn that into a decent number. I can say 11/18. 8/10, Frank, times 12.8. I included a decimal, it's now going to tell me a decimal. I can always say, no. Write that as a fraction. Do what I tell you. And I can call it 352 pi over 45. Okay? That is the most accurate answer. If I'm going for my area, we're going to do pi by 12.8 squared by 110 out of 360, or 1/2 11 pi over 18 by 12.8 squared. Again, do, because, what? Oh, he even said be careful. And then he wasn't careful. Unshaded region. Most common error on these is to just miss that entirely. If 11 pi over 8 is, or 18 is the shaded region, then the unshaded region is 7 pi over 18. Wait, 2 pi, hold on. Hey, 2 pi minus 11 pi over 18. The unshaded. I missed un. 110 degrees is the central angle for arc AB, the shaded area. So this needs to turn into, if it's 110 here, it's 250 unshaded. Or 36 minus 11, 25 pi over 18 for radians. Good catch, I hang my head in shame. No, because that one said find length of AB, and then the area of the unshaded region. So they're looking at two different regions. Oh, good catch. And jam it all into a calculator. Write it as a fraction if you can. 1/2 times 25 18ths, just because I don't trust myself to do math right now. 12.8 squared. Suppose you might want to multiply in there. Insert times. Nope. So I get nastiness, I change it back to a fraction. 1024 over 9, pi. Yep. Yeah. Be like 350 something. And then, as we approach, I won't give my horrible rendition of the final countdown. As we approach the end of times, we got to start doing some review here. Pay very close attention to the directions. Pay close attention to the directions. We've gone through a lot of things in this class. I know and I believe that every one of you could solve this by I feel lucky and synthetic division. I know you could. But we have covered factoring by grouping of quartics. I'll tell you that every form of the test, this is factorable without split method, because I reverse engineered them so they'd work that way. Stage 1, look for your quadratic forms. X to the 4th, 13x squared plus 36 with a negative 2x cubed minus 18x over here. All I did was rearrange that line so that I could see my quadratic form. Now that I have that quadratic form, I can factor each of these. What's usually going to happen is in a quartic that is factorable by grouping, it's going to be A, B, A, B, A. Every other term is going to be able to be grouped together. Okay? A's over here, B's over there. Next up. This is in quadratic form. It looks like a duck, it quacks like a duck. Turns out it's a goose. I can treat it just like a quadratic where factors of 13 add up to, or factors of 36 add up to 13 are 9 and 4. But in A and X, it's x squared. Over here, we got just plain old GCF. I'll take out a 2x, leaving x squared plus 9. Sorry, negative 2x. Yes. Why does it have to be negative? Otherwise, the signs would be different. I'd have a negative x squared minus 9. I see that they both have an x squared plus 9 in common. I'll take it out. And when I do, everything that's left gets written. X squared minus 2x plus 4. Last I checked, there was not a factor pair of positive 4 that added up to a negative 2. So that means I have to solve this guy, this time not however you want. You got to complete the square. And the reason we got to do it is because after this chapter, we're going to do conics, and that's where you got to complete the square twice per problem. Okay? So, step 1, variables left, constants right. I'll subtract the 4 over. Step 2, eliminate the Canadians, divide by A. In this case, there is no A value besides 1, so I don't have to worry about that. And then the magic number that you add to both sides is always b over 2 squared. Half of negative 2 is negative 1. Negative 1 squared is 1. Getting a perfect square trinomial, x minus 1 squared is negative 3. Solved by square roots. Square root both sides, getting x minus 1 is plus or minus I root of 3. Add the 1 over.
Did you go from, you added the one? Oh, and you factored it?
Yeah, it's a perfect square trinomial. The reason we're doing this is to make it factorable like this. So I got x is 1 plus or minus I root of 3 or root of 3I. I don't care. Just be careful how you write root of 3 and then an I, so we know I isn't inside the radical. Over here, well, that's a lot easier. It's sum of squares. Remember, difference of squares, if that was x squared minus 9, would be x plus 3, x minus 3. Because it's sum of squares, what changes? Solve by square roots and see what happens. A sum of squares factors exactly like difference of squares. It's just, you got i's in there. Meaning, x is also plus or minus 3i. It's a quartic with 0 real answers, which is another reason why I said by factoring and complete the square. Okay. Scramble yourselves up. Get rid of your devices. Here we go.